Today, guys, we're going to work on question 30 from your current homework. It's on page 33, and it says an object initially traveling at 20 meters per second south, that's pretty important, accelerates uniformly. Now, guys, this may be confusing, so let's read it again. An object initially traveling at 20 meters per second south accelerates. So it's traveling this velocity, and then suddenly it accelerates uniformly at 6 meters per second squared north. Now, these directions are going to be very important in this problem, and it's displaced by 25 meters. Now, guys, this is where I dislike this problem a lot because it's pretty annoying. You guys should realize this pretty quickly, that if this is a displacement, it should give you a direction. So, well, what direction is this displacement going to be going in? Well, let's assume, guys, let's assume that the displacement is going to be south. It's going to be traveling south. So here is our object. Let's draw it. It has a velocity going south, initial velocity, and it's going to have an acceleration going north on it. But the acceleration, it's smaller than the velocity. It's going to slow it down, but it's going to end up someplace down here to the south. Now, we'll see later where this is a bad example because it doesn't really tell you the direction of the displacement. I digress. Let's get back to identifying things. So, the first thing I want to say is let's identify our variables. What variables do the problems give us? Well, it says initially right here. This is very important. Initially. So its initial velocity, it's vi equals 20 meters per second. I'm going to say south right here. And then it says it then accelerates uniformly. Now, guys, this is why we memorize the units, because you may want to say, well, why isn't this acceleration? Well, look at the units, guys, meters per second. It can't possibly be acceleration. But you look here at this one, and you say 6 meters per second squared. That has to be the acceleration because it has the acceleration unit. So, guys, sometimes the English in these problems is a little bit difficult to understand. The main thing I want to stress, guys, the units will never lie to you. Okay, and the last thing, we said we have a displacement equal to 25 meters, and we're going to assume it's south, guys. Remember, I said it was driving south, it has an acceleration going against it, and it's eventually going to end up somewhere in the south. Now, to the south. Now, we'll see later why this, once again, this problem is very bad with its vagueness. So the first thing I want to do, guys, is talk about north and south. And when we look at this right here, we'll see that we have an xy axis. And if you actually label your directions on an xy axis, you'll see something very interesting happens. Now, you guys are very familiar with the xy axis. Here's the x, and up here is your, or up here's the y, up here's your positive y, and that means down here is your negative y. And over here is your positive x, and over here is your negative x. Now, what I want you to think is this, guys, is when we're dealing with norths and souths, they can be combined together. Do you see how they are in one dimension? And that's very easy for us to add together. So this problem is not too difficult because we're only dealing with one dimension motion, or linear motion. So once again, these are going to be either positives or negatives because we're looking at our axis again. If we're going north, let's say it's positive. So here we have north, let's say that's positive. And here south, and south is negative. South is negative. So this is going to be negative and negative. And this is going to be something, guys, that's reoccurring throughout the entire year. So make sure, if you don't understand it now, ask me a question. When we are doing these, we're going to have to give our directions a positive or negative in this case. And we'll also see, guys, it's going to be very difficult to add norths to, let's say, east because they're on different axes. What you'd have to do is you have to add them together head to tail. But since we're not perpendicular, we're parallel, we can simply treat these numbers by positives and negatives. Okay, so this is what we have. Now we need to look at the question real quick. The final velocity of the object is, so we're looking for our final velocity, so I'm going to put that right here. Final velocity equals a question mark. So I've said this is what I have, and this is what I want to find. This is what I have, this is what I want to find. Okay? I highly stress, guys, before you start working on a problem, you do this. Write down what you have and what you want to find. So let's take a look at our reference table. Now, the front page is your list of constants and stuff. It's not going to give you any formulas to solve this. Well, here's your electromagnetic spectrum. Gamma rays, they have that kind of frequency? I didn't know. Here's some absolute indices of refraction. Maybe we'll get into refraction this year, but it seems unlikely. Here are energy level diagrams. Those are pretty cool. Different types of matter, particles of the Standard Model, electricity, not what we're talking about now, but also very cool stuff. Waves and optics, modern physics, geometry and trigonometry, cool stuff. Now here we are in mechanics. And so far, guys, this year, we've really only talked about, let me Control-Z that. We've only talked about stuff, and maybe just stick with the formulas, stuff over here. So we've talked about these 7 formulas. Now, this is your average velocity formula, but it could also be, remember guys, it could also be your constant velocity formula. Because remember, when you're traveling at constant velocity, your velocity is your average velocity. Very important. Now, here's your acceleration formula. And in fact, guys, one thing I really want to stress, these 2 formulas right here are actually the same formula. Because if you rewrite this one, A equals VF minus VI over T, you can rewrite this one and you get this exact same one. So these are really actually the same formula. Now, let's take a look again at what we have. We have VI, A, and D. So let's find formulas that have VI, A, and D. So this one has VI, A, but it has T. No. This one has VI, A, but has T. No. This one right here has VF squared equals VI squared plus 2AD. Yes. Let us use that one right there. Okay, so let's go back to our do now, and let's write that one down. Let's go look at it real quick. I forget. VF squared equals VI squared plus 2AD. VF squared equals VI squared plus 2AD. Okay. So now the next thing all you have to do, guys, is just simply plug your variables in. So you're going to say VF squared equals parentheses -20 meters per second quantity squared plus 2 times +6. That 6 will look a little better. 6 meters per second squared multiplied by our distance, and so that's -25 meters. Okay, I'm going to close that out. All right. So once again, remember, guys, everything that's going south is negative, and everything going north is positive. And that'll help us out with our formulas. So now, -20 squared is going to give me 400 meters per second. Now this, remember, I've squared this, so a negative times a negative gives you a positive, but I also have to square my unit, so this is squared, and this is squared. Plus, now I'm going to go 2 times 6 times 25. Well, 6 times 25 is 150. Imagine you had 6 quarters, that's $1.50. 150 times 2 is 300, but remember it's negative, so you're going to have a negative 300 meters squared per second squared. Now, this should be pretty simple, guys. 400 minus 300 is going to give you 100. And we can say that these things are equal, so you have VF squared equals 100 meters per second, or meters squared, second squared, and then you have to take the square root of both sides. So you guys know square root of 100 is 10, square your unit, that's going to give you, in fact, when you take the square root of both sides, you'll get VF, sorry I'm making my V's so big, equals 10 meters per second. Now, here's the thing though. This number could be positive or negative. So it's kind of an annoying problem to have. Remember guys, when you take the square root of a number, that number could be positive or negative. So in this case, this is going to be our final answer. A little ambiguous. This thing could be going 10 meters per second north or 10 meters per second south. It's kind of a pretty annoying problem, but make sure guys, oh wow. I will follow up in a